Now that we've discussed the motions, let's talk about each planet individually, starting with Mercury. So Mercury has a very similar appearance to the Moon. Both of them are very, very heavily cratered. Now, based on what we talked about previously, what does this suggest about the geology for Mercury? If you remember previously, this suggests that there is no ongoing geology, no volcanism, no tectonics, no erosion and weathering. All of these processes would destroy craters. So this suggests that Mercury is a very old surface with no ongoing geology similar to the Moon. Mercury also has low-lying lava plains similar to the maria that we found on the Moon. And in fact, when we look at crater counts and so on, trying to figure out how old they are, they appear to have roughly the same ages as the Moon. Now, one prominent feature we see on Mercury that we don't see as much on the Moon are these long cliffs. So you can see it here in this picture. These long cliffs are known as scarps. These are scarps along the surface of Mercury. We think that these likely formed due to Mercury cooling. Generally, as objects cool, they tend to shrink. So the idea is that when Mercury first formed, it was very, very hot, just like all the other terrestrial planets, because of accretion and differentiation. However, because it is much smaller, it has cooled off, and as it cooled, the interior shrank. Now, the crust had already become rigid by that point, so as the interior shrank, then the crust had to crack and resettle because of that shrinking. So it's kind of like an old apple, how old apples kind of get wrinkly. A similar thing happened, but instead of wrinkles, we actually get fractures and cracks. These are likely the scarps that we see. Now, one interesting feature we find on Mercury is a giant impact basin. So that's this yellow region here. Something really, really big slammed into Mercury, so big that it actually carved down into the mantle. This impact was so strong that it actually created concentric rings of mountains. So the ripple that came from this impact created rings. When we look on the opposite side of Mercury from the Caloris Basin, we find a region of highly jumbled terrain. The impact of the Caloris Basin was so strong that the shock wave actually blasted material out from the opposite side of the planet. I would love to see this. This would have been amazing. Now, based off of flybys and so on, we've been able to figure out Mercury's density. When we do, we actually find that Mercury has a similar density to that of the Earth. It's just a little bit less dense than the Earth is. Now, at first, that seems like, yeah, of course, they're both terrestrial planets. They're made of the same stuff. They should have the same density. However, there's one really big difference. Earth is much larger. It has a much higher mass, which means it has greater gravity, squeezing everything down. So we actually expect the Earth to have a much higher density than what we find for Mercury, and yet we find that they're actually relatively close in density. So what this suggests is that there's actually a larger iron core, that Mercury has a greater iron content than what we see for the Earth. Now, this is weird, and we need to be able to explain it. So what's our go-to explanation anytime there's something weird with the planets? Giant impact. So maybe early on, we had proto-Mercury that had the same ratio of rock to metal as what we see for the Earth, and then it got hit really hard by some other protoplanet or planetesimal. This collision would have been so great, it would have vaporized the mantle and rock layer, at least a lot of it, and shattered the core. Because the core was inside and more protected, this would have allowed it to then reaccrete, but a lot of the outer rocky layers would have been left and gone, disappeared. So in the end, when it reaccreted, it would have had a much higher metal content than the iron, than the mantle, than the rock of what we actually should be there. Now, one interesting feature of Mercury is that it does have a magnetic field. It's not as strong as the Earth, but it is present, and it does actually protect the surface of Mercury from some of the solar wind. Now, for any planet to have a magnetic field, there are three properties that it has to have. There has to be an electrically conducting liquid in the interior. This liquid has to have convection, and the planet has to rotate fast enough. Well, for Mercury, the big problem is number 2. The interior of Mercury should have cooled off enough that there shouldn't be convection in the core anymore. It should have settled down and not actually have any motion. So what we believe is happening is that we get something that is like convection. It's not actually convection, but it has a similar property. Specifically, we think that the outer layer of the core is solidifying, and as it solidifies, it's going to sink towards the interior. As that happens, it's going to churn, cause the rest of it to actually begin to cycle. So it's cycling like convection, but it's not actually being caused by convection. This is our best guess as to why Mercury still has a magnetic field.